Good morning. Welcome to the next session. Now, in this session, I am going to talk about streaming mining used in the data science. So, I am going to talk about what is streaming mining, how the data flow from stream, and how to mine the data from the stream. So, what is stream mining? Streaming data analysis in real time is becoming the standard to obtain useful knowledge from what is happening right now, allowing organizations to react quickly when the problem appear or to detect new trend, helping them to improve their performance. A very simple definition is this. Now, what is streaming? On the flow data is coming from the source, and you have to mine the data and you have to find out the pattern. For example, people are watching the movie. So when they come out of the theater, okay, they would like to give their feedback as movie rating, good, bad, chalta hai, so, excellent, things like that. So this kind of data which is coming from the source, which is on the stream, on the fly, is called as stream data. So stream data can come from a resource like a IoT device, it can come from a remote location, it can come from the mobile data, it can come from any of the source which is connected to the internet. So streaming data analysis in real time. So whatever information I am getting on the movie analysis, let us say it is the real time data. Fine. So it's becoming standard to obtain useful knowledge. So what is my knowledge I am getting? How many people did like the movie? How many people appreciated the casting? How many people appreciated the dialogue and things like that. So that is what I get a knowledge from what is happening right now, allowing organization to see the problem quickly appearing or find out a new trend. So if I want to locate a new trend, for example, if the movie was very good and if the movie was not very good, I will be able to detect a trending analysis. So this trending analysis will help me to improve the performance. So streaming, you can see here, you can see in the diagram, data is coming from various sources. So you have a stream of the data coming from various number of sources, and MOV is one of the moving data analytics, okay, and it is being very popular by a University of Waikato. A, a very good course. See what we have to do with the big data analytics. So information gathered, our information capacity is doubling every 40 months. Okay, and our RDMES data set databases packages are incapable of handling such huge amount of data. That's the reason we go for a big data analytics. So big data is a new driver for digital economy and society, and Gartner report says that hundreds of billions of the GDP, okay, by 2020, okay, an intangible factor after labor and capital, and data science is the fourth paradigm. So it is a intangible factor after your labor, intelligence, everything, okay, and then data science is basically a coming for as a fourth paradigm in the technology. So the power of big data can bring big values to our life, almost every what we call aspect. So you can do the analysis, you can do a predictive analysis, or you can find out if the movie will be successful or not, or if the store is putting some new item, will it be sellable or not, or will it be profitable or not. So this kind of analysis are very good handled by power of the big data. Further, technologically, big data is bringing about changes in our life because it allows diverse and heterogeneous data to be fully integrated and analyzed to help us to make the decision. So people would like to see the caption, people like to see the photograph, people like to comment on the video and things like that. So you have a heterogeneous of the data and people will make the comment and it will help to analyze and to make a better decision for us. Today, with big data technology, thousands of data from seemingly unrelated areas can help to support the important decision making. Okay, so this is the power of the big data. Application, health and well-being, policy making and public opinion, smart cities, new online educational model like MOOC and student teacher modeling, robotics and human robotic interaction, and much of this power lies on the research of the analysis. So big data analysis or big data analytics and research has become a very powerful tool. So let us see some objectives. So big data analytics objectives as just see. So we can apply for online shopping, smart cities, health, financial and risk management, genetic farming. So you can see here on the bottom side you have web data coming from the web, we have city data coming from the terrestrial of the city, okay, or physical location of the city. We have financial data, we have logistic data coming from various sources, okay, like a supply chain model. Then we have agriculture data, we have a sensor data like a IoT device. So all these disparate devices are giving me the data, okay. So web, city, financial, logistic, agriculture, and what we call as a sensor IoT device. All this different data are being extracted, are being put together, called as data extraction, and after data is being extracted they are integrated into a homogeneous form. From this it will go to big data computing and the data management technique, and then from there we go for the data mining and visualization technique. So you can see here I can have a risk analysis, I can do a genetic farming, I can do a health being analysis, I can go for a smart city analysis and things like that. So these are some of the applications of the big data objectives. So what is big data in the streaming? So conventional machine learning algorithm setting, that is called batch processing, operate assuming that training data is available as a whole set. So whenever I am training a machine learning model, or whenever I am training a deep learning model, the assumption is the entire data set is available for the training as a whole. However, any example that can be retrieved as a needed for the detailed cost, but this is not the case with the big data analytics which is coming on the streaming. An alternative is to treat the training data as a stream. So as on the fly data comes in. So your model is not a stationary model, become a dynamic model, or model become a moving stream data model. A potentially endless flow of the data that arrives in an order that cannot be controlled. So you can see here the data is coming from the microwave oven, data is coming from a IoT device, data is coming from a smart city, from other resources, okay. Even the petrol pump data can also be collected. So all this real time data are coming as a stream form, and this stream form is going to be processed. So that is what we call as a big data streaming, and we can use the our data science algorithm to analyze and try to learn about the streaming data mining. So what is streaming mining? An algorithm capable of learning from a stream, by definition a data mining algorithm. So on the fly I should be able to learn about the, okay. So placing classification in a data stream suffers from the several setting offers several advantage. An example of such application is monitoring a high speed traffic network, where unending flow of data is too overwhelming and can be considered and storing for and revisiting. So you can see that the data is coming from enormous number of nodes, and which we do not know. So a stream of item, also called an instance or example, that are continuously arriving. So whenever millions of the people are using the internet, it is nothing but a stream data. So main algorithm in data streaming mining algorithm are classification, regression, clustering, and frequent mining pattern. So most of the things we have already studied, okay, and under machine learning course and our data science course, okay. So we know classification, regression, clustering, and then frequent mining pattern we have already done. So classification and regression need a set of properly labeled data example to learn from the model, so that we can use this model to predict the labels of the unseen example, that is your supervised learning, and we can use a supervised and unsupervised both the way learning process. When examples are not labeled, okay, one interesting task is to group them in a homogeneous cluster called as a unsupervised learning. So clustering is a unsupervised, otherwise everything else is supervised. However, pattern mining, okay, looks for the most relevant pattern in which within the example. For instance, in a sales supermarket, it is possible to know what items are being bought together. We have already seen about the pattern association rule in our data mining in earlier lectures. So it is possible to know what items are being bought together and to obtain association rule. Okay, we have already talked about association rule. So most time customers buy cheese, they also buy the bread and sausage. So anyway, we know all this associated rule in our data mining earlier lecture. So the most significant requirement for a stream mining algorithm are the same as predictor, clusters, and the frequent mining patterns. Okay. So what is the requirement? We have 5 requirement. Number 1, process an instance of the data at a time, inspect one by one, find out, use a limited amount of time to process each instance. So as a data is coming on a stream, process the data and try to learn what is the information available in requirement number 2. Requirement number 3 is a use a limited amount of memory, because I cannot have a enormous or a unlimited amount of memory on the fly. So use a limited amount of the memory and be ready to give an answer, that is your prediction, clustering or pattern at any time in the data analytics on the stream. So this is exactly the process. And then adapt to a temporal change. Temporal means time. So adapt your algorithm changing with the time. So this 5 requirement tells me a beautiful answer, that you can process the instance with a limited amount of memory, and then you can do the analysis using prediction, clustering pattern, and then you can go for a temporal analysis. What are the use cases of a streaming data? So a streaming processing system is beneficial in most scenarios where new and dynamic data is generally continuously available. It applies to most of the industry segment and big data use cases. Companies generally begin with simple applications such as collecting the system log and then rudimentary processing like rolling, mix and mix computation. Then these applications involve more sophisticated near real-time system. So some of the examples like data analysis. Application process data stream to produce reports and perform action and responses such as emitting alarm when the key measures exceed a certain threshold. More sophisticated stream processing application extract deeper insight by applying the machine learning algorithm to business and customer activity data. IoT, we all of us know, Internet of Things devices are another use of the streaming data, because the data is coming from a temperature sensor, data is coming from a pressure horn sensor. So this is coming on the fly. So we can apply the sensors in vehicle, industrial equipment and farm machinery, send data to a streaming application. So from the farmhouse also we can send the data to the streaming processor unit. The application monitor performance, detect potential defect in the advance and automatically places a spare part order, preventing a equipment downfall. So this is very good for the people who are in the farming industry or farmer. Okay. Financial analysis, financial institution use stream data to track real time changes. So stock market, okay, like a stock market compute value of the risk, okay, and automatically balance portfolio based upon the stock prices movement. Another financial use case is fraud detection of credit card transactions using the real-time inference against the streaming data. So whenever a fraud is happening, okay, on the fly, streaming data analytics will give me a beautiful application. Real-time recommendation algorithm are available for consumer mobile and make the real-time component, okay, of the places to be visited or properties to visit. Similarly, advertising, food, retail and consumer applications can integrate real-time recommendation. Service guarantee, you can implement data stream processing to track and maintain services levels in the applications and equipment. For example, a solar power company has to maintain power throughput for its customer or pay penalties. It implement a streaming data application that monitor all the panels in the field and schedule services in the real time. Thus, it can minimize each panel period of low throughput and associated penalty pay layout. Media and gaming. So media publisher streaming data, okay, and record from the online properties, aggregate and enrich the data with demographic information and optimize content placement. This helps publisher to deliver a better, more relevant experience to the audience. Similarly, online gaming companies are using stream data processing to analyze play game, okay, interaction and offer dynamic experience. Risk control. Live streaming and social platform capture user behavior data in the real time for risk control analysis and for financial security and application, such as recharge, refund, reward. This view of real time dashboard is flexible to the strategy management. So you can see that streaming data analytics play a very critical role in the data science, and you can do a stream analysis to find out the behavior pattern, the predictive pattern and then machine learning algorithm, apply machine learning algorithm for the purpose. Thank you.